This is Module 1, Introduction to Upper Air. Upper air, or aerology, is the study of the upper atmosphere. On Sable Island and other sites, the upper air program consists of launching high-altitude balloons that carry electronic instruments into the atmosphere. These instruments measure atmospheric conditions and radio their data back to the station. At the station, a computer system analyzes the data and prepares data messages that are transmitted to our regional headquarters on the mainland, and from there they're transmitted around the world. This upper air data is of primary importance in weather forecasting. The upper air program is based in the operations building. At the upper air desk, the technician is starting his flight preparations. The electronic instrument attached to the balloon is called a radio sonde, or sonde for short. The instrument takes three primary measurements: temperature, humidity, and pressure. The sondes also have a GPS receiver and are able to calculate the wind speed and direction. The balloon shed stores lifting gas and provides a space to inflate the balloons and launch them. Once the flight equipment is prepared and launched into the sky, the balloon ascends. And as it ascends, it expands and keeps expanding until eventually the balloon bursts and everything falls back to Earth. The balloon typically takes about 90 to 120 minutes to get to burst altitude. Sable Island is one of 32 upper air stations in Canada and one of more than 800 upper air stations around the world. All weather stations in the world use the time zone for Greenwich Mean Time. Times are indicated in the 24-hour clock, for example 0700, 1430, etc., but followed by the letter Z as an abbreviation for GMT. When spoken, Z in the phonetic alphabet is Zulu, so 11:15 p.m. GMT is written as 2315 Z and read out loud as 2315 Zulu. There are 2 upper air flights each day, every day, rain or shine. They occur every 12 hours and are referred to as the 0 Zulu ascent and the 12 Zulu ascent, the so-called standard hours. Sable Island is in the Atlantic time zone, so the 12 Zulu ascent occurs in the morning and the 0 Zulu ascent occurs in the evening. The balloon ascent can average more than 90 minutes long, so by releasing 45 minutes before 0 Zulu and 12 Zulu, we can have the average duration of the ascent centered on the standard hours. The morning ascent is launched at 11:15 Zulu and the evening ascent is launched at 23:15 Zulu. On Sable Island, that corresponds to 7:15 a.m. and 7:15 p.m. during the winter when we're on standard time, and an hour later in summer when we're on daylight savings time. It takes about an hour to prepare the flight, then 2 hours for the flight to ascend, and then additional time is needed in case problems develop. So the total time for a flight is about 3.5 hours. In the winter time zone, the morning flight starts at 6:15 a.m. and ends at 9:45 a.m. And similarly, the evening flight starts at 6:15 p.m. and ends at 9:45 p.m. As you go up in the atmosphere, you already know that it gets colder, and you probably also know that atmospheric pressure decreases as you go higher. This is an actual temperature profile measured over Sable Island. It shows that on this particular flight, the balloon ascended to about 37 kilometers above the surface before the flight ended. You can see that at the surface the temperature was around 12 Celsius, and immediately above the ground the temperature rapidly increased to 19 Celsius. If you consider the average slope of the temperature profile, you can see that on this day the profile could be averaged into 3 segments. At the top of the first segment, the slope of the temperature curve changes fairly abruptly. That level is called the tropopause. On this particular day, the tropopause was located at an altitude of 10,668 meters. The atmosphere below the tropopause is called the troposphere. This layer of the atmosphere is important because most of the clouds, rain, and snow are contained in this layer. So what we generally consider the weather happens inside the troposphere. Above the tropopause, we have the layer called the stratosphere. The stratosphere contains the ozone layer, where ozone absorbs ultraviolet light, releasing heat, and that warms this layer of the atmosphere. Looking at the pressure scale on the right, you can see the atmospheric pressure doesn't decrease uniformly as we ascend. We measure pressure in units called hectopascals. Near sea level, the atmospheric pressure is about 1,000 hectopascals and diminishes rapidly as we go up. We only have to ascend about 6 kilometers before the pressure is reduced by half to about 500 hectopascals. At an altitude of just over 15 kilometers, the pressure is down to 100 hectopascals, a reduction of 90% from the surface value. Typically, we'd expect our balloons to get above the 10 hectopascal pressure level, but the size of the balloon, the weather conditions, how the balloon is handled, how the balloon is inflated, and manufacturing quality all determine the performance of the balloon. So while we can't predict how high the balloon will go, Environment Canada has established a performance target of 400 hectopascals. If the balloon gets to that level, we've successfully profiled most of the troposphere. But if the balloon doesn't get that high, we consider the flight unsuccessful and we prepare another sonde and another balloon and we try a second time. Since the sonde also measures the relative humidity, we can look at the moisture profile over Sable Island. Dry air is on the left and humid air is on the right. Where the humidity approaches 100%, that indicates cloud layers. At this particular time, there were 3 cloud layers in the sky. Similarly, since the sonde also measures pressure, we can look at the change in pressure over Sable Island. We can also look at the wind profile. The wind direction is measured in degrees and the wind speed is in knots, the same as used in aviation. The wind speed at the surface is 19 knots, which is typical, but you can see that the wind speed rapidly increases to 48 knots only 300 meters above the ground. Again, this is fairly common on Sable Island. On this particular day, the maximum wind reported is just above 10 kilometers and is from the west, or 270 degrees, at 75 knots. The maximum wind can vary considerably and sometimes gets up to around 200 knots when the jet stream passes over Sable Island. If we compare the wind profile to the temperature profile, we can see that the maximum wind speed often occurs near the tropopause. For displaying this data, we can change the label of the scale on the bottom and have it extend from about -80, the coldest temperature we might see in the atmosphere, all the way up to 100, which is the highest humidity we'll see. This allows us to plot both the temperature and humidity on the same graph. Similarly, we can put the pressure scale along the top and then add the pressure curve to the same graph. Now we have all 3 measurements plotted at the same time. Why do we bother? Because the ground equipment we use will show this type of graph when displaying the atmospheric profile you're measuring. All 3 measurements plotted simultaneously on a time or a height scale. Finally, each upper air station has a letter identifier and a station number. For Sable Island, the letter identifier, called the station ID, is CWSA, and the station number, called the synoptic ID, is 71600. The entire atmospheric profile is summarized in a group of numeric data messages, and these are transmitted electronically to the Maritimes Weather Center on the mainland and then relayed around the world. There are 6 different messages, and each is referred to by the letters in the message header. The US, UK, and UG contain the data between the surface and 100 hectopascals. The US and UK contain the temperature, humidity, and pressure data, and the UD just contains the wind data. Similarly, data above 100 hectopascals is contained in the UL, the UE, and the UQ messages. Again, the UL and UE contain temperature, humidity, and pressure data, and the UQ is just wind data message. Note that the header line for each message contains the station ID for Sable Island, CWSA, and the message body contains the station synoptic ID, 71600. This completes the introduction to upper air.